So guys, we're gonna go ahead and find the area of a rhombus now. So you're gonna notice just by looking at the formula that to find the area of a rhombus, it's exactly the same thing as the area of a kite. So again, if you know your diagonals, you're gonna be set. There's a few properties I want to go over first before jumping in straight into area. And it is that a rhombus is pretty much a slanted square. And as such, all sides are the same. Opposite sides are the same, making it a parallelogram. And since it's a parallelogram, you're going to notice how the opposite angles end up being the same. And I didn't indicate that over here, but your diagonals, one, they bisect each other. So like if you knew this was 3, this automatically is 3. And okay, and if this was 6, this is 6, right? So that's very important. So diagonals bisect each other. And secondly, because it's a rhombus, the diagonals will make up that 90. So again, you're going to see how we have those right triangles. Again, very important properties. Opposite sides are the same. They're all the same. And notice how the angles end up becoming angle bisectors. Okay, so that's important. So let's look at this example right here that I have in the bottom. So automatically, if that's 4, that's 4. If that's 3, that's 3. Remember how the area was the same as a kite? And it was just d1 times d2 divided by 2. Well, right now I know that one of my diagonals is 4 plus 4. And the other diagonal is 3 plus 3. I got everything I need. Now I just multiply them. So it's 8 times 6 divided by 2. 8 times 6 divided by 2. So the area of this rhombus is just 24. Okay, and I know they look very similar to kites, especially the way I cut them out here, but it is just a parallelogram. Sometimes you'll see it like that, sometimes you'll see it like this instead. But again, you're gonna know it's a rhombus because all sides are the same. And the cool thing about these is, again, these two are the same, these two are the same, and on the kite, only one set was the same. Alright, a few more problems, just some examples here. So right now they're telling us that on this one that all the sides are 10. So if one side is 10, I know everything else is 10. They're telling me that this one is 6, so automatically this should be 6. In order to find the area, I need to know my diagonals. Right now, I know one of them, but I need the other one. Remember how both in a kite and a rhombus, the diagonals intersect at a 90-degree angle. So we have a right triangle. So in my right triangle here, I know that this is 6 and I know this is 10, and I am basically looking for this piece right here. Right? This piece is that piece. And once again, I know my c, so Pythagorean theorem. 10 squared minus 6 squared. Okay, which is going to give us 8 if I'm not mistaken. But let's be safe here. 10 squared minus 6 squared. And it's 8, yes. So now I know this is 8. And if that's 8, that's 8. And so my other diagonal is 8 plus 8, which is 16. Again, I have enough info now. It's just 12 times 16 divided by 2 to find my total area. And so the area of this rhombus is 96. So again, notice when you can use Pythagorean theorem. Very important you know when to use it. We look at the one below it. We have this rhombus. I went ahead and I labeled it with letters. Oh, I wasn't going to have enough space to put the stuff here. they're telling us that this angle right here, angle DAB, this angle here, all of this is 120 degrees. Well, I want to remind you that in a kite, your diagonals cut it in half. So if I know that this whole thing is 120, well, now I know that this is 60 degrees, just like that. And that also, this one over here is 60 degrees. And same thing over here. They're telling us that AB is 6. And again, we know that there's a 90-degree angle. I don't know any diagonals at the moment, and I have to find them. So I will go ahead and draw my right triangle. I usually like to draw them the way they look in the picture so that I am able to not get confused as to what represented what. But it doesn't matter, that's a preference. So again, I know this is 60 degrees and I know this is 6. Two things you could do law of sines or SOHCAHTOA. Again, I'm a fan of law of sines, so I'm going to go ahead and do that. So law of sines, we have to find both diagonals. I'm just going to call this part x for now and this part y. So using the law of sines, if I wanted to find x first, x is across the angle 60, so sine of 60. The 6, which is what we know, is across the sine of 90. You can only have one unknown in your setup. I only have one unknown, so it works out. So 6 times the sine of 60. And then I'm going to have to divide by the sine of 90. And then I keep repeating myself here. The sine of 90 is just 1. Doesn't do anything. So again, 6 times the sine of 60. So I found out that x was 5.2 basically. Now I'm going to go ahead and solve for y. I'm going to do the same thing. Here the angles should add up to 180. So this is 30. Y is across the angle of 30 degrees. And again, I'm just going to use that 6 again. Sine of 90. Again, I'm going to cross multiply. So it's going to be 6 times the sine of 30. And then whatever I get, I have to divide it by the sine of 90. And in this case, I get the same thing. So y I found out to be 3. So this is 5.2. And if that's 5.2, that's 5.2. I found out this to be 3. And if that's 3, that's 3. So one of my diagonals, 5.2 plus 5.2, is 10.4. Whereas my other diagonal is basically 6. The 6 is the blue one, okay? And this 10.4 represents this red one. And all I have to do now is just multiply. 10.4 times 6 divided by 2 to find my area. And so the area here is 31.2. And that's how you find the area of a rhombus. Very similar to the kite, just that now we're going to take into consideration angles at times and be prepared to do either law of sines or SOHCAHTOA.